the channel Notion of Mathematics. In today's video, I will be discussing two questions with you, and this particular video is related to the short trick to find eigenvalues, right? So if you see, there is one question. In this question, I have considered one matrix, 2 by 2 matrix. It is 2 by 2 matrix, right? And the entries are 1, 2, 0, and 4. So question is like we have to find the eigenvalues of this particular matrix. So I have already discussed that how to find the eigenvalues of any matrix, square matrix, right, in my previous videos at the channel Notion of Mathematics. But in today's video, I will be telling you what is the modified form of the characteristic equation with the help of which in very easy way you can find the eigenvalue. So here I have written one here I have written one, I will say this particular characteristic equation. Okay, this is the updated form of the characteristic equation and it is for 2 by 2 matrix. It is for 2 by 2 matrix. So what is this particular characteristic equation's updated form? That is lambda square minus trace of A into lambda plus determinant of matrix A equal to 0. So lambda square is as it is, right? What is the trace of this matrix? That is 1 plus 4. So it will be 5 into lambda as it is and plus determinant of this matrix is 4, so that is plus 4 equal to 0. So after that what I have done, I have just factorized this particular equation. So minus 5 lambda I have written like minus 4 lambda minus lambda, and thereafter I have factorized it by taking lambda and this minus 1 common, so it will give me lambda minus 1 and lambda minus 4, and ultimately two eigenvalues are provided, that is lambda equal to 1 and 4. So in very easy way, with the help of this particular characteristic equation, we can find the eigenvalues. Now, if we see the second question, in this second question, I will say I have taken one matrix. I mean to say 3 by 3 order. It is, and the question is like we have to find the eigenvalues of this particular matrix. So again, what I have done, I have taken the characteristic equation for 3 by 3 for 3 by 3 matrix, but it is having the updated form. So what is the updated form of this particular characteristic equation? This is the updated form. This is the updated form, and that is like lambda cube minus trace of A into lambda square plus A11 plus A22 plus A33. These are the cofactors, right? Into lambda and minus determinant of A equal to 0. So lambda cube is as it is. What is the trace of this matrix? That is 1 plus 2 plus 4. That is 7. So it is minus 7 lambda square and plus A11 plus A22 plus A33. These are the cofactors. I mean to say A11 is cofactor with respect to this, but for this particular element 1, that is 2304, that is 8. 8. A22 is cofactor with respect to this particular element, that is 1304, that is 4, right? And A33 is a cofactor with respect to this particular element, that will give me 1202, so this will be 2, right? And into lambda as it is, and lambda as it is minus what? Minus determinant of this particular matrix, that is 8. That is very easy to calculate. Now thereafter I have simplified this particular equation and I obtained this particular equation here. That is lambda cube minus 7 lambda square and plus 14 lambda minus 8 equal to 0. And thereafter, what I have done, I have tried to factorize this particular equation. As I have knowledge that lambda equal to 1 is one root of this particular equation. So I mean to say, I have written this particular equation in this form. Okay. So I have taken lambda minus 1 as a factorized term, factor it is, and then this particular equation is obtained, and thereafter again I factorize this particular equation, which gave me lambda minus 2 lambda minus 4. Ultimately this particular equation we will obtain, that is lambda minus 1 lambda minus 2 lambda minus 4 equal to 0, which will provide us three eigenvalues, lambda equal to 1, 2 and 4. In such a way, students, if you can see, with the help of these modified characteristic equations, we can very easily find the eigenvalues. So these were the eigenvalues for 2 by 2 matrix, and these were the eigenvalues for 3 by 3 matrix. So in such a way, you can find the eigenvalues. So I hope this will be very helpful for all of you. So thank you so much for watching this video.